Hi. All right. 1 second.
Gotcha. I'm gonna grab Joe. Will you tell some jokes or something?
Joe. Tell some jokes.
Oh, I think you're up. Is that you?
Yeah.
So we don't need Joe.
No Joe.
Awesome.
Wow. A hush came across the crowd. It's nice. Okay. Thanks for coming, everyone. Thank you, Chartboost. Yeah, who here is from Chartboost? All right. One person. Yeah, Chartboost, actually, I think you guys are a Databricks customer, right? I think you're actually one of the first Databricks customers. That's my own company. Oh, yeah. 1 second. Yes, I always forget this part.
Hey everybody, thanks for coming. My name is Ryan. I work here at Chartboost. Just a couple of logistical matters. Drinks you can finish up yourself. There's some pizza left. Restrooms are through that door right there, and there's a little sign that has a passcode to those restrooms. But information's here. Just briefly about Chartboost, we are a monetization platform for mobile game developers around the world. We work with over 300,000 games. We're being used by over 300,000 games at this point. They deliver to over 1 billion mobile devices around the globe every month. And we're here to help game developers to user acquisition, monetization, that's a lot of data and analytics so that they're better business decisions. Based here, we have a small office in Amsterdam as well, and we're leveraging Spark and Scala and serving and relevance data engineering teams. We'll have you guys here, and we'll give us plenty more of these, so we'll see you around. Back to you.
Okay, so today I'm going to do just sort of quick like meetup announcements. This is the first time I'm doing the Zoom thing for, so yeah, it's sort of live streaming here. I think you guys, the Wi-Fi password's there. What is it, Nerds at Play? I posted the link to, I guess you guys are here, so you don't really need it. But so we have 3 talks. I'm going to do my little intro, kind of blabbering, non sequitur, try to keep up with my brain. Talk on the latest with Pipeline. I think I mentioned this last time. I sort of like renamed things to PipelineAI instead of IO, and I got like 8,000 VC invites on LinkedIn, and I'm like everyone's best friend now in the Bay Area. There's money coming out of my ass. No, that's not true at all. And then we're going to have Ramesh actually speak last. And then I've got my buddy Brendan McAdams. Yeah, right, like McAdams? No, oh yeah, McCord. I was trying to find you in LinkedIn and I kept doing McAdams. I have no idea why I thought that. Brendan McCord is from Department of Defense, a group called DXIU. Yeah, like DXIU. They're using TensorFlow. And yeah, Brendan like attacked me after a meetup in New York, I think, and wanted to talk, and he had moved. I guess they just created this group. It's the AI Center of Excellence for Department of Defense. We can thank Donald Trump for helping facilitate that. That's a joke. Just hope he doesn't tear it down. So Brendan moved from the East Coast and is building up a group here. He's a super connected guy, good to know. So he's going to explain probably use cases. That was some feedback I've been getting about this meetup is that it's very technical, that's good, but we still want to see how people are actually using TensorFlow. So, and then Ramesh and I met, I don't know, yeah, many times in the past, and I ran into him in Seattle, and then he said he would love to speak at the meetup, and I was like, what are you doing next Tuesday? And he is here to speak. So he's going to talk about Keras, PyTorch. Yeah, who here is using Torch or PyTorch? Oh, really? Oh, wow. So yeah, that's kind of cool. So you can ask him all the questions you want. And I guess let me just kind of get into it here. So real quick, one thing I've been focused on recently is sort of building or incorporating in UI, right, like into Pipeline. It's traditionally a lot of command line stuff. That's cool. These VCs that are throwing money at me really want me to produce a UI. So one of my buddies out of Chicago runs this company GuildAI, and they're actually an open source project. Go to guild.ai. And he was showing this to me in reference to like a way to package up your TensorFlow models and push them out somewhere and train them. And so much like most of the other sort of, right, like machine learning AI frameworks and products like Domino and these guys kind of stopped at the serving layer, right? The actual prediction and like deployment. So that's where I came in. And it's not really fully incorporated yet, but I can show you the different pieces and you can kind of imagine the two coming together. So this is like literally about a week old of integration work, and that's where a lot of these screenshots come from. So what I'm going to do is, so from working with a few different customers, right, we've like come to realize that one pain point is what people build their model on and train in is different than the production environment, right? So this is a common pain point. They push something out, it's a different version of Scikit or NumPy, whatever. So the ability to have the exact same environment, right? This is one of the reasons Pipeline was created. Just hadn't, you know, like before Docker for Mac, before Docker for Windows, right? Like this was difficult. You know, like you couldn't reproduce production environment. So what I'm going to demo here is a TensorFlow model, and I'm going to package it up using Guild. This is all on my local laptop. And then I'm going to train the model. So it's a little bit, you know, like the data set's not that big, but just kind of work with me. It's going to train itself and then serve itself inside of this same exact Docker image. So it's not something you would necessarily want to scale out, but it's actually kind of a cool idea, right? So just sort of mentally, you know, train and then deploy, and it's all inside of one Docker image. And I've got like Prometheus and Grafana set up for the system metrics, and I've got Guild for the training metrics. So like, and then yeah, I'll show the UI here, but like imagine being able to see, you know, like columns of this is what happened at training time, this is the accuracy, this is validation accuracy, and this is how the model is performing in production, right, like alongside the other models. So, you know, think of this continuous experimentation thing, which is something Pipeline has been working on for quite some time. Okay, so I'm gonna have to put the mic down. We don't have a, so I'm just gonna yell really loud, but close that. Yeah, so this part's only about 5 minutes, and then we'll get into the good stuff. So. All right, so this part, yeah, this is all local. So yeah, I'm calling this, yeah, so there's this PIO command line interface, right? You can pip install PIO-CLI. It's all Python 3, so yeah, 2.7, it's not gonna be pretty. So what this is doing is, like, there's this sort of shell Docker image that is kind of useless, right, like without an actual like TensorFlow model. So, and specifically, I backed up into the pipeline enough where it's actually gonna do the training. So all that this Docker image needs is the .py file. And then from there, it's hooked into Guild, which is very simple. It's just, you know, those dash flags and all that stuff that, you know, TensorFlow like examples use. And those flags, like learning rate and batch size, those show up inside of Guild, inside the UI. So you can kind of, and so what I'm doing here is I'm actually, I guess you can call it hyperparameter tuning. So so I'll get into that in a sec here. But when I ran PIO model build, this actually slurped in the .py file. So let me show you that. First, I'm using trusty MNIST. All right, so this is sort of a cleaned up version of like the existing like MNIST example, sort of highlighting, you know, these are the different parameters. The one parameter that we're trying to tune and observe with a small data set is this learning rate. So I'm going to pass in 3 different learning rates, and it's going to train on the small data set, and then it's going to show it in the UI. And then we'll actually like predict from the command line into the local Docker image, right? So we can simulate predictions using REST and all that stuff, and sort of get a sense of the actual performance for these models. All right, so there's nothing magical here. It's all just low-level TensorFlow code. Instead of hard coding the learning rate, we're passing it in that way. And just by using these, oh yeah, this is all open source, by the way, in case some of you tuned out. Just by using these like global flags, then it gets hooked into the Guild UI and all that stuff. So. All right, so I run PIO model build. It's going to slurp in that PIO train. This Docker image can't do anything unless it has a model. And now, this way. I'm going to do PIO model start. Also, you can pass in dash GPU. This is on my local laptop, which does not have a GPU. I used to, and someone stole my laptop. So this is actually starting it. I can look at the logs, and this should show some training. Now, the training step is optional, right? Like you don't have to have a train, or like you don't have to pass in the .py. You could just pass in the train binary. But if it recognizes PIO train, it'll start training. And then when it's done, it's actually going to do the 3 different learning rates here. And then it's going to start up. So this is going to be localhost. And the Guild UI is on 6333. All right, it's doing the last learning. Great. All right. Starts up the model server, the TensorFlow model server, starts up the UI. Don't worry about those errors. Zoom in here. Oops. All right, and so the best view to look at is this compare view. So here's all 3 runs. There's the time it took. We can like click on these. We can actually compare the runs. That's obviously what we're looking at is the accuracy, the like validation accuracy, training accuracy. So this is where I'm saying like you kind of have to use a little bit of imagination. I'm going to show you guys the live running model as it's taking predictions. And so like imagine like a third column here that's showing sort of roughly like compared to the control model that's out there, right? Like there's an existing cluster. How well is this new model scoring? So this is kind of a quick. It's sort of extending the model validation step into production on live data. Okay, so yeah, one thing we could do here, so we're still, in the UI is doing some weird stuff here. There's the different learning rates, things like that. Let's click refresh here. And then this has native integration with TensorBoard as well, so you can go and look at the actual images. You can look at the different runs. So there were 3 different runs. There was a training and a validation step for each run. You can look at histograms. Yes, everyone loves a good histogram. You can look at the graph. In theory. Okay, so let me, now I'm going to break out of here. Let me just clear this. So I'm still on my local laptop. I'm going to be hitting the local Docker image, or it's running Docker container. So like essentially what I've done is like sort of hydrated this Docker image and this model, and then brought it to life, right? Make it like a full executable. And if I do the model dash predict. This first prediction takes a sec, has to kind of warm up the TensorFlow serving. Let's run it again. So this is actually hitting local. I've got this little mini load test you can do. Concurrency is 50. Let's do 100. And it's just going to rip through, and it's using the Python like create process in the background. And let me just show you guys, just the last bit of this will be the Grafana stuff. So now this is actually showing that model and how it was taking traffic and different counts and things like that. So we've instrumented these models when you deploy them as part of this Docker business. You actually get insight into, like not only how long did it take to physically predict, but also like the time it took to convert the JSON into a tensor or like NumPy array, and then separate from that is the prediction time, and then third is the response, like converting it from a tensor back into JSON to be returned. So I'll just show you guys real quick, new dashboard. So here's a prediction counter. And if I load this up, let me change the refresh. That's all this is going to get integrated into the same UI, right? So you won't have to do this. And let's do some more predictions here. Concurrency is 250. And we should see a blip over here. So like these are simple metrics right now, but at some point either tonight or tomorrow when I get around to writing it, it's going to show the comparison between these different models and how they're like doing in terms of like prediction performance. right? So imagine for the same set of inputs, like the ability to see how these different models are predicted. So, so like quantify that, right? So in this case, it's returning a classification. And what we would do is post to like Prometheus, which is the metrics collector, the max of this, right? So what is this? Yeah, it looks like in this case it'd be 0, 1, 2, and then right, like quickly see, yeah, how is this new model predicting against the right, like the current model? And if it's wildly out of tolerance, then you would tear it down. If it's doing well and you're comfortable with it, then you would scale it up and then take out the current model. All right, so that's where we're at there. I think, oh yeah, this shows you also, I can click on it, yeah, so it looks like this is coming up now. So you can compare the different runs, the learning rate, things like that, right? It's pretty much the same thing here. Yeah, so that's that. This is all a single Docker image. It's about 7 gig. So yeah, like we have to work on that. Clear your hard drives, take all your family photos, toss them out. You don't need your family anymore because you have TensorFlow. Yeah, Brendan, do you want to come up and say a few syllables?
All right. So
Speak into it, yeah. You gotta manhandle it.
So Chris asked me to come here and kind of frame the project that I'm working on. You guys are actually the second audience to hear about this. So the first one was last week. Eric Schmidt, Defense Innovation Board. We've got a group that was set up by the last Secretary of Defense in the last administration to bring in tech company leaders. Eric Schmidt's one of them, Jeff Bezos, Reid Hoffman, and they are kind of like the advisory group for the DoD. And so we presented this idea for an AI Center of Excellence here in Silicon Valley. That's all so a lot nicer than anyway. And hopefully you guys don't have the same kind of comments that Eric had. It's pretty tough, tough audience. No, but it was good, and he was really excited about it. It's exactly the right thing to do. So they're super commercial case, and it can be accessed from anywhere that has its in Silicon Valley. So my background, really quickly, I came from Boston 2 weeks ago, moved with one-way ticket, 4th of July weekend. And in Boston, I was leading a team of people that was half deep learning research scientists and half software engineers at a startup that brought together Bill Gates as personal investor and then also Intel, strategic investor for the intelligence community. It's a really unique startup and a good experience. Before that, I was on a submarine for 610 days underwater, really pretty cool mission. So I kind of had kind of experiences here and came out to get this off the ground and really to get the test bed component off the ground. So I wanted to talk about that as an interesting use case for for data pipelines for TensorFlow. And so what we're trying to do there, and what I'm spending a lot of time thinking about and want feedback on, is how to provide the right blend of data sets and problems and compute and people to be able to help the Department of Defense make progress. So data sets are things that the DoD has a lot. They're not labeled. There's a lot of raw data. But starting later this month, and again, you guys are some of the first to hear this, some of the, I don't know that anybody would report this, but a lot of the military folks are going to be converted into like mechanical Turks. People spend 12 hours a day looking at imagery or getting how people works. So we're going to get a lot of data sets that are suitable for deploying. But examples of the kinds of things we have are the kinds of satellite data, or there's a platform called an optical bar camera that lives in like the nose of a U-2 plane. And if I show you that next to the Google Earth images, the only difference is that one's grayscale and one's color. It's incredibly similar. But then there are also data sets around like all the sensor data from F-16s. Use cases there. lots of documents. Turns out DoD has a lot of business with paper documents. We want to be able to start to automate and transcribe those things. Health records, logistics data, on and on. So we're pulling together a lot of this data and trying to charge it with a problem, so it's not just like broken data. Yeah. I don't know what that is.
That's the
Summary. You know, a U2 plane. Yeah, but I came from somewhere. I'm not German.
yeah.
So Chris is and so anyway, yeah, like predictive maintenance stuff. You know, lots of these interesting problems. And some of the data sets are just frankly very cool. Like synthetic aperture radar data is really cool and analyze it. So data sets with a problem, with metrics, with an interested data customer within theory. The other thing is compute. So we're getting a PGX1. We'll have it down in our facility. We'll have cloud compute that we'll be able to get people to be able to use. So for folks who are in companies or privately want to work on problems, they can do so. So a lot of emphasis on that, providing that. And then people. So we set up a bunch of new hiring authorities to be able to build a small team. And Chris was actually there on Wednesday when we had this talk discussion with some folks from Facebook, and we're doing some interesting things around there. So we can bring people on to start to kind of work on problems. My group was the three people who kind of lead that. One of them was at Google X and was like the internal guy who ran COO. One was an entrepreneur here in the Valley, and then another guy wrote the big data policy for President Obama. He helped us think through how to find the policy. So pretty new outfit. I lead that testbed effort. And what I would say is I'd love to talk more about use cases. Ways to get involved are we're making this a test bed that can be used to engage commercial companies, which means not just letting them play with data, but letting them actually get contracts with the government in a really quick way. So we have some special authorities from Congress to get contracts done in 60 days. So if you think you're working on something that might have an analog in this organization, which is the DoD, we'd like to talk about it. And we want to have people who can tell us how to do this. So hit me up afterwards. My email is Brendan, BRENDAN, @diux.mil. And we'd love to show some demo, later on once we've got a couple things built for this test. Anything else I should cover? Make sure I hit all the high points.
You want to talk about multi-domain?
Oh yeah, so really quickly, a couple of interesting challenges are that one is cloud and on-premise. So clearly, the way you do this in a commercial setting is you rely on cloud. Within DoD, they're really slow to do that. They have a lot of space, physical space, a lot of computers, and so we're trying to think through how to approach that. Like, if cloud is going to take them years. We kind of we're going to build along the whole continuum, but try to think through how we can make something that's deployable within areas of DoD. Other issue is that the networks are stratified into unclassified, secret, top secret. They don't talk to one another. And so this multi-domain problem is really tricky for machine learning pipelines because you have data that exists up here, but you have a lot of unclassed data that's a good proxy for it down here. And so you do something like transfer learning to be able to apply it to data that's kind of like locked away in other inaccessible networks. And then just how do you think about the training to serve a pipeline extending into these places which are kind of hard to access. There's a lot of interesting work if you want to do sophisticated things like the kinds of things Chris works on. How do you incorporate that if you're kind of putting it over into the multi-domain? Nobody's figured this out from what I can tell. I don't think had a solution for it either. But those are the kinds of problems that I think would be interesting systems engineering as well. So one is involving overhead imagery, trying to detect a range of objects. So we're funding the labeling of a bunch of data. It's going to be the largest overhead object data set that exists. It's going to have 80 classes of objects. It's going to be focused on like disaster mission, so a lot of things will be around, like emergency vehicles and things like that. But it's going to push on 3 computer vision frontiers. One is a lot of small objects, another is a lot of rare objects, and another is objects of multiple types, so like rigid, well-formed, as well as mini scenes, like power plants and things like that. And we're working with a number of like top people behind MS Coco and a number of top computer vision academics to like scope that. That's one problem. The reason it's important is there are hundreds and hundreds of people who analyze pixels and do so without algorithms today in DoD. Kind of mind-blowing. That's one. The predictive maintenance one that I mentioned around sensors, like it's an aircraft in that case, but it could be a ship, it could be a tank. There are a lot of assets that have instrumentation. We need to do a better job of managing that. The documents one, anybody who works on like back office documentation stuff, that all needs to come into modernity in DoD. We have a healthcare portfolio. I mean, a lot of the DoD stuff is honestly the same as the commercial realm, which is part of the time. Yeah, I think it is. So one of the key requirements here when thinking through the test bed was portability. To have any model that's expressed in the test bed be runnable on a data center or a desktop or an edge device. And there's a separate special challenge around running with IoT type as well. So we want to make sure that. So each use case has some problems like that, but that's stuff normal. Yeah, no, so it's a good question. So the way we frame these things is like we put up a problem, predictive maintenance, and then we get people to team up as they see appropriate. So you can imagine like a subject matter expert who knows predictive maintenance, aircraft or whatever, combining with someone who's got a platform for easily making sense of temporal something like that. And that could be a great team. They just come pitch, and the way we do it is like they just show a demo where they do a pitch like. It's not like the standard government way of putting together a lot of white papers. So you can kind of like self-organize and bring a team that can tackle the problem. Is somebody back? Yeah, I can. I think we could probably do that offline, but that's live right now. So that's very, very recent. Maybe we could do that over email follow-up. But that's, it's aircraft sensor data, and we're trying to attack some, be able to identify it. All right, well, Brendan at diux.mil again. I'm glad Chris is perfect. Yeah, so let me know. I'd love to have follow-up.
Sweet. All right, Brendan, thanks. All right. Oh yeah, Brenton, like were you, yes, on the sub, right? Like, did you guys have Netflix? Really? On the Navy ships, do they have Netflix? Because I swear, like when I was at Netflix, like one of the other times I took down streaming, the studios made us put in all these IP checks when Netflix started going global, and we didn't have a whitelist of some branch of the government in some weird place that I didn't even know they had TVs or signals, and we somehow shut them off Netflix, right? Because we were walling up just the U.S. Yeah, we forgot about Puerto Rico, we somehow managed Hawaii, and then we shut all the government secret IPs down, which are probably not a secret anymore. They're in a Google Doc within Netflix. But all right, yeah, you ready? Ramesh is the man. Just think you could work with these two fine-looking men. All right, man. Do you want to?
I can use your laptop.
Yeah,
I can do it. I have a short link for the Zoom thing. Yeah, go for it.
It's really sensitive.
No worries.
Is it I'm?
Yeah, IQDEMX. Sorry. This is what you meant. It's really sensitive. Okay. That is a mouse. That is my mouse. Okay. Wait. All right. Hopefully. All right. Hello everyone. My name is Ramesh Sampath, and I want to share with you my experiments working with TensorFlow, Keras, and PyTorch, and I'll post these slides on the Meetup page afterwards. Just one small announcement. PyBay, the regional Python conference, is coming in 3 weeks. So if you are free that weekend, check it out. Yeah, last year I had a chance to hang out with Armin Ronacher, the Flask creator. So, you never know who you bump into in these open source conferences. All right. Just a bit about me. I am a machine learning engineer. I recently did the Insights AI fellowship, and I have less than 6 months experience with deep learning. So there may be questions you will ask me that I will say I don't know. That truly means I don't know. And I'm here to just share my understanding of these frameworks and hopefully help you get started. And I may just be just a couple of steps ahead of you. So yeah, so I just want to put that in perspective. And this is what I'm assuming is that you are familiar with supervised learning and particularly logistic regression, because we'll be doing binary classifications. All right, so I just want to put the big picture out there. What is AI? And we're talking about machine learning, right? Machine learning is a subset of AI, okay? And we should not forget the traditional machine learning models, which are applicable in many, many instances, particularly when you do not have a lot of data, or if your dimensions are not very big, like images or sometimes even text. So, yeah, please don't forget these are the ones that actually work. And deep learning is just one more tool in the toolbox. Okay, it's not something totally different. It's just one more machine learning technique. And this whole box, I truly don't know. So when somebody says AI, I don't know what is all the things in AI. I'm only going to focus on the machine learning piece of it, and specifically the deep learning piece here. All right, so some of the slides I actually took from CS231 course. You can see the link here directly. So here is all the, they put a good collection of all the deep learning frameworks particularly, and all of them are of course open source. And we're going to just talk about TensorFlow and PyTorch today, but acknowledge that, the one on the right, they all came this year, most of them. CNTK got open source from Microsoft, Paddle from Baidu, and I'm sure more will come. Okay. There's almost like this front-end frameworks, like Google released Angular, Facebook released React. There's kind of this flavor to things. All right. So what's the point of deep learning frameworks? And they really got, the third point is the most important one we'll talk about, is they actually run it very effectively on GPUs. And they actually build a computational graph. We will look at a few of them, and they allow you to easily compute gradients on this computation graph. All right, so imperatives is declarative, and this, so just to get some terminology out there, tensor is not just for TensorFlow, tensor is for all deep learning frameworks. So you have the scalar, vector, and matrix, and these are, of course, in all machine learning tools, you would need this, Python or just how you do manipulation of data. So just want to call out how you would do this in Torch. When it says Torch, it's really PyTorch over there. So Torch, you will just give a Python list or Python value, and then it returns you this Torch array. And tensor is just an n-dimensional array of values. Okay, so PyTorch really plays well with Python lists as well as NumPy arrays. So you see over there, you can convert a PyTorch into a NumPy array. Just the torch tensor.numpy will give you NumPy array. You can go the other way where you can convert a NumPy array into PyTorch by just saying from NumPy, and you get this. And you can actually, with the third thing is the most useful thing actually. You can do indexing just like do any Python indexing. You can even do the -1, -2, all sorts of indexing works. Okay. And if you actually look at TensorFlow, this is what you will get. If you actually do the same thing in TensorFlow, you will actually not get the values. Okay. It's actually creating a computation graph. Okay. So nothing gets computed until you put it inside a session object and run the session object. So this is what I mean when we say imperative versus declarative. So in PyTorch, when you type something, over here it's all Jupyter Notebook cells. When you type something, it actually executes it, computes it, and executes it right there, just like how Python lists and NumPy arrays do. Whereas in TensorFlow, it's implicitly creating a computation graph that you would need to run it explicitly afterwards. Okay, so let's talk about computation graphs. All right, so this is a computation graph where the node C is x times y, so x times y plus z. So that's all the C's computation graph is here. C is a summation of x times y that comes through the object A here, and then it adds z to it. And you see how you would do this in NumPy. Okay, so here you say you declare the variable x, y, and z. These three are the input variables. And then you calculate the intermediate nodes A and B, and you do C equal to numpy.sum of that A plus Z. All right. And then if you need to do gradients on this step, if you need to go back up on this gradient on this step, you'll have to do it all by yourself. Okay, you'll have to compute the gradients and calculate it, by hand. There is no function in NumPy to do this for you. Okay, so there's two problems here. One, you have to compute your own gradients, and two, it cannot run on a GPU. All right, so how do you do this in TensorFlow? Okay, you see, like there is a lot of similarity in there. That same x, y, z exists there. The same a plus a comma b, and then you see c, which TensorFlow does reduce sum. It's really it's basically doing summation of the array or the vector there, and then it's calculating gradients, and then it still doesn't do it doesn't run anything. It just computes the graph at that point. So you see there, you're creating the forward computation graph, or you're defining the forward computation graph, and then you are calculating the gradients with respect to C. So it says TF gradients C comma x y z. You're calculating gradients on C with respect to x, y, and z. Okay, and then you're running that all inside the session object over here. So it is really here is where the actual values get computed. Okay, here is how you'll do it in PyTorch. Okay, you declare the variables. Okay, so you declare variables x, y, and z. You will do the forward pass. Okay, a, b, c. Okay, right there. and you do backward propagation over here. And that's it. There is no session object. You don't explicitly create a graph. There is no graph being explicitly created. It's actually getting implicitly created over there for you. Okay. So let's talk about this. So in PyTorch, this is the main difference between PyTorch and TensorFlow, in my mind, is your variable holds data and the gradients. Okay, so let me go back one step here to show you that. You see the last step here, how I printed those values. You see x dot gradient, y dot gradient, z dot gradient. That's because when you compute, when you do the back propagation on C, it goes back here, computes the gradient, and stores those gradients in those variables themselves. Whereas in TensorFlow, okay, you will see in the next slide actually also, but you will see here, the gradients are not stored with these placeholders. Placeholders are just ways to feed data into the system. So gradients are kept separately. Okay, so so because the gradients are stored with the variable, you can actually do a lot of things with it. When you are debugging some things, you can print the gradients, you can plot the gradients, you can do a lot of things very easily in PyTorch, which are you need to run it inside a session object, and in your debugging, you'll have to modify the code in TensorFlow, whereas in PyTorch you don't have to necessarily. Okay, so here is all three of them side by side. Yeah, so you don't. This obviously PyTorch is the most of them. It's really just. And PyTorch really tells you that it is just Python. Like it is nothing. You don't explain. There is no new ideas and concepts to learn that you will have to inform in TensorFlow. Okay. Yes.
I see CUDA up there.
Yes. Okay. Yeah. CUDA is how you put a PyTorch variable into GPU. So in TensorFlow, you do this thing with tf.device, and you put it into the GPU. tf.device. If most of the time you don't have to do it in TensorFlow because it will automatically put it to GPU. But if you want it to use CPU, you'll have to say tf.device/CPU. So, and then the problem with that is actually that is part of your graph building code, right? And you don't want that to be part of a graph building code. You want to, take that piece of code which is actually because you may have multiple GPUs. So if you want to use multiple GPUs, then it can be a problem if you do this approach. And TensorFlow APIs changes all the time, so there may be a better way of doing this. Yeah, so in PyTorch, by default, it goes to CPU. You'll have to explicitly call CUDA to put it in the GPU. It's a good question. All right, let's build a simple logistic regression, okay, and through which we will walk through the different components of all three. So we'll do a binary classification. There's two variables, x1, x2, and then there is two classes, 0 and 1, and it's very clearly separable. Any model will separate them. We don't need a deep learning for this problem, but it's good to look at a small computation graph and understand it. All right, so this is really what the computation graph is, just broken down in steps. You have x1, x2, two variables, and then you have this z, or also score or logic, is just a weighted combination of x1, x2 with a bias term, and then you apply them through a sigmoid function to convert it, to bound it between 0 and 1 that looks like probabilities. Okay, and that's often used as a probability, but it's just to bound it to 0 and 1 most of the time. Okay. So in TensorFlow, this is how you define this graph. So this term often comes up in TensorFlow versus PyTorch. Specifically, is define unrun and define by run, and you'll see this here. So when you define the model, you are actually defining the computation graph, and actually, if you just start putting variables into it, it will automatically put it into the default computation graph. And that sometimes can be a problem if you are inside Jupyter notebooks and you run the same cell multiple times. So I like to create a graph object manually. You see the first line over there, G equal to tf.graph. I like to create the graph object manually, and then I will explicitly use the with statement to add to this graph. So I know what's all the things that's part of this graph. So if you don't do this and you run it, you know, when you go to TensorBoard, you will see your graph is way bigger than what you actually thought. There will be duplicates in the graph. All right. So, all right. So yeah. So yeah, I'm creating a X data and Y data as two placeholders, but data will come in, and then the actual model in those 3 lines highlighted over there. You define the weights, you define the bias, and you calculate the logits, which is matrix multiplication of your data and weights, and you add bias term to it. Okay. And this is how a lot of TensorFlow tutorials will show you that you should do. You could do, but TensorFlow has learned for a while that they should actually be promoting layers. So this is really where Keras came in play and did a lot of things. There's no reason not to use it in TensorFlow. And also, you see that it's no longer in contrib.layers, it's actually tf.layers, which means it is part of the core TensorFlow that they intend to maintain. So you should always, you know, go ahead and use it. If you want to use it, you know, just for a few small problems, that's fine. But I think, and people have created their own little functions that actually does the same thing, but you could also use the tf.layers over there. Okay. And then when you run the graph, you explicitly run it inside a session object. Session is what holds the data. And you see here, when I run the session object, I'm referencing the graph. So if you don't do that, it will use the default graph and run the default graph. So I have, I've gotten used to this paradigm of creating the graph explicitly. And when I run the session, I will also pass the graph into the session object. That way, even if I run the cell multiple times, it doesn't cause any duplication. Okay, and here is the training loop. So the training loop is for that many epochs. It runs the training operation for this given data of X and Y. And there is the valid, you know, the prediction step where it just extracts the output of the values. Okay. All right, yeah, so this is one important point. Session is the one that holds the state of data and weights. So if you want to save the model and save the model weights, it needs to be done within this session context. So if you come outside the session context, there is no weights being saved. So all the weights are inside the session context. That's why it's explicitly, you run the graph here. So how do you do this in Keras? So in Keras, you don't actually define a graph, although it creates a graph for you. So you create the model like that. So you just say, I want a dense layer, and then you can give a name to the layer. And then here I'm using a sigmoid activation function, and then that's how you define the model. And then you run the model by doing model.compile with the loss function and the optimizer, and then you run the model through the fit method. Okay. So one nice thing in this is that there is no session object you need to worry about, and you can actually save the model at the end of this step. So it's much more approachable, and that's why a lot of people use Keras when they get started. This is how you'll do it in PyTorch. Okay, so definitely a lot of lines, okay, compared to even TensorFlow. Okay, so but I do want to highlight a couple of things here. So this is the define by run paradigm. Okay, so you explicitly do the forward pass on the model. Okay, and then you do the backward pass by zeroing out the gradients, and then doing a backward pass, and then asking the optimizer to make one step towards the backward pass. So you see the first 3 lines here, you are defining the model. Okay, you're defining the optimizer. You're actually instantiating the model. Actually, instantiating the model, you are saying what optimizer you want, what model parameters you want to update, and what is your loss function. And then you are explicitly giving the training loop. There is some similarity between what this does and what TensorFlow does. Yes. Yes, so optimizer, you provide the model parameters to the optimizer. So here on this third line here, so that's how it knows what parameters to update. So you can specify what specific parameters to update during the optimization process. Yeah, okay, great. Okay, so of course, all these models do well. And then the color over there tells you the confidence that the model has that, that it belongs to any one of those two classes. All right. So one thing you notice is that when you define the model for PyTorch, it looks very similar to Keras. So it's got this higher level API, which is in torch.nn, torch.neural network, which gives you this Keras-like model definition. So that's the big draw of PyTorch, is that you don't need multiple libraries. You just ask, you can go up and down all of this. In fact, MXNet also has the same thing. MXNet also has a module that is similar API. That's one of the reasons why Keras backends do not have a PyTorch backend to it, because there's no reason for it. So Keras has only 3 backends: Theano, TensorFlow, and CNTK, the Microsoft framework. All right, but that's not deep learning, right? So deep learning is just taking that y equal to f of x function and just attacking more and more layers on top of it. Okay, but otherwise it's the same thing, and the loop is all, everything's the same. Okay, so this is from the deep learning book. So if you are passing in a much more complex set of inputs like images, then you need a hierarchical set of features. So each layer learns a few things, few basic elements, and then they build on top of each other before it gets to the final classifications. And I just want to share with you how I used this approach to build an application using PyTorch. Okay, so I had this, I was working with one of the startups down in South Bay, where they needed to classify images and extract features like whatever shirt it is, whatever sleeve it is, and things like that. And they were doing it manually, and they were trying to see, can the machine learn this task? Okay, and for this proof of concept, I had access to about 2,000 images that were hand labeled. The references here. All right, so so this is how I built the model. I took these images. Because there is only 1,800 images, I had to basically do data augmentation on the images to create different variations of it, ran through the VGG network, and then built a 4-layer convolutional model, and then the predicted values at the output. Okay. Once this is done, I saved the model weights and then deployed it inside an app. Okay, so we'll look at a few of these right now. And it doesn't take that long to train, is because I'm not tuning the VGG model. I'm just using the VGG model as it is. I'm just removing its fully connected layers and adding my own 4-layer network on top of it. So 4-layer is not that deep of a neural network, if you think about it. So data augmentation. Okay, so data augmentation is necessary in almost all projects because you will never have enough data that is labeled. So you will have to create variations of this data, and Keras gives this image data generator object in a pre-processing module that you will see in a lot of references, and you will see that there's like 25 different options, and it is 25 different options because it probably, I'm guessing, had a few options initially, and somebody said, oh, we need height shifting, we need a different shifting, flipping. Like all these were tagged on, and now you have 25 different options. It's great. So which means it covers a lot of them. Okay, but there are going to be a few cases where it does not cover it, and there is a pre-processing function that you could provide, but it's also pretty wonky as to what you can provide to it. And I want to contrast this with how PyTorch does it. In PyTorch, there's something called compose. Okay, so you compose all the transformations, which means the ones that says transforms dot, they were provided by PyTorch. So they had a random crop, they had a random flip, okay, and they had a normalized function, okay, but they did not have a scaling through a tuple, and I was able to add my own scaling function to it, and somebody else had written a library to do some other variations, and they were, it's much easier to add them to this compose function because because you can just layer on top of each other, and you can just layer what you want, and you can layer some things for your training and for your when you do your validation or testing, you may not want all the different layers. So there's this idea of minimal API provided by the library, and then you add on to it is very powerful, and I think that's one of the big draw for PyTorch. Whereas TensorFlow, if you go to TensorFlow by extension, I would say even Keras, they try to provide you everything. Like the API is just unwieldy. It's like even if you do something like dense or conv, you'll have con 2D in layers, con 2D in Keras.layers, you will have con 2D not as a layer, but as actually as an operation, convolutional operation. Like they try to provide you all sorts of things, which is good if you really know the API. But if you're coming new to the project, it's really hard to know where to get started. And so yeah, another nice thing about PyTorch is this normalized function. All their model zoo frameworks like VGG, ResNet, they all have the same normalization function. So they don't have different normalization for different networks. So it's kind of nice. So you can swap these networks very easily. All right, so the code is here. I'll share the slides later as well. So I'll just go to this app here. It's a very simple app. So you can just select anything, any one person, or you can upload an image. I'll tell you everything about the person. This is this. It takes the scarf as V-shaped neckline. It does say that this person is wearing a scarf. So you can take any image, or you can upload a URL here. So it's an app that just queries the server and gives you results. We'll look at it. Here. Oops. Okay, so what does it do? It actually uses the Tornado as a web server for this process. So when it gets the input to the predict function here on the bottom here, once the authentication is complete through the simple auth key, basic authentication, it actually, because Tornado is a async framework, it needs to be a little bit non-blocking. So you yield and get the pre-trained features, and then you see this next step here where I yield and then I give a dictionary, which means it's actually running in parallel. It yields and runs all the different models, in parallel, and then collects all the results and then sends back the results. And that's why you can see that it's a little bit more instantaneous than running each one of those models independently. So yeah, so any machine learning model you do, you must always do a confusion matrix on it. You can see that suits are classified very nicely because they're very distinct. Whereas sweater, it has a really hard time identifying sweater, maybe because sweater is worn on top of a dress. So there's some, mix of sweater with other things. But also you will see there is not that many examples of sweater. So maybe there is, that not having enough unbalanced data also could be a problem over there. Yeah. Okay. But you really want to get an intuition on the results. So you want to know that is the machine actually looking at the right things? Is there a leakage in the data? Like, is it looking at some background, arbitrary background, and then telling you that it's something like it's a long sleeve, and actually looking at, some person's pants and saying it's a long sleeve, right? So you want to make sure that the machine has the right, they're looking at the right place in the image when it makes these predictions. So you can, I don't know if it's clear to see over there. One thing you can see is the first one, the scarf over here. You see it's actually looking at the area around his neck when it says this person is wearing a scarf. Similarly, when it looks at gender, you can see area around the face is the one that's getting activated. And sleeve length, of course, is also that it's using the left sleeve over here, and so on. Okay. Yeah, I'll get to it next. Yes. Yeah. And similarly, in these pictures as well, you can see that, for example, you see the third one over here, when it says this person is actually wearing outerwear, there is definitely leakage over here. But looking at the background of where this picture was taken to define that it's outerwear, although it does look at the skirt area as well, but there is definitely leakage from the background of the image. And that's also good to note that it's actually not very confident it's outerwear. So that's so useful. So how do you do this? So how do you get convolution layer outputs in PyTorch? Okay. So this is the whole model right there. This is the entire model network, and because it is a Python class is how you define these models. You see this every PyTorch model inherits from nn.module, and then I have this optional parameter is return convolutional layers as false. So when I query the model from the web app, it doesn't return these convolutional layers. Okay? But when I'm introspecting this model from within my notebook, Jupyter notebook, then I will say, hey, return convolution layers true, and then it will actually return me in its forward propagation. So when you define the forward propagation, it will return me not only the class output, but also the convolution layers. And this convolution layer is just one, you see here, let's see, yeah. When it runs the convolution model, it gets the conv layers of, here is the model actually. It's missing here. Okay, yeah. The last line over there, nn.sequential. It's running all these steps. It's basically running through my 4-layer neural network. It's really only 4 because it does a batch norm, con2d activation of ReLU, batch norm, con2d activation of ReLU, and yeah. So and because of this, this is why it makes it easier, because it's just a Python class, and when you instantiate, you can decide what things you want out of it, and this is something you cannot do this easily in Keras or TensorFlow. You can certainly get the outputs of the layers in both frameworks, but it is a little bit more work than this. All right. So I also want to talk about the current status of these projects and whether it's applicable to you. So this is PyTorch version 0.12. Okay. And I want you to look at this line. We are an early beta release. Expect some changes. Okay. Although I have to say that the API has actually not changed. Surprisingly, API has not changed, whereas TensorFlow API has actually been changing even after 1.0. So 1.0, 1.1, 1.2, it's actually been changing quite a bit. But the PyTorch API has not been changing, mostly because there is not that much to the API. It's only a few things. It's got an NN module, it's got an autograd module, and it's got the basic matrix manipulation modules. And here is all the companies that use it. And you'll see doesn't say use it. Companies, just developing PyTorch, right? So that's not using PyTorch, okay? But although Facebook does use it, although they also have Cafe, so Cafe 2, so maybe they're using Cafe 2 more, but it doesn't say using here. Whereas, if you contrast that, well, I'll talk on the next slide here. But if you want to start using PyTorch, or at least experimenting with it, the GitHub page, if you go there, you'll actually see all the different projects that's part of PyTorch. You'll see PyTorch, you'll see Vision, which is all the transformations, everything with respect to the images is in Vision. There is text, everything with NLP is in text. So and then you have tons of examples and tutorials over there. Okay. Whereas we go to TensorFlow, it says companies using TensorFlow. So it's different words over there, but it clearly gives the impression that it's ready to, for you to use it rather than experiment with it. And it's also version 1.2, that's 0.12, that means anything. Okay, So this is something that's been talked about in PyTorch forums. They are very active discussion forum as well. So here is unscientific way of putting these bars together. So you have TensorFlow and you have TensorFlow serving. So you can export your TensorFlow models into TensorFlow serving, and then you can have this distributed scalable application. With PyTorch, okay, you can certainly deploy like the way I did, which is how you would traditionally deploy machine learning model as an API. But there is also some talk about exporting PyTorch models into Caffe2 or some other frameworks so that PyTorch remains research friendly and does not expand its code base into making it more distributed and production scalable, so keeping the APIs small. Whereas some of the other frameworks like Caffe or maybe even TF serving, I don't know, can remain a little bit harder to set up, but they are much more scalable with respect to deploying and production. So this is an useful mental model. All right, the things we did not talk about, okay? So visualizations with TensorBoard. There is gist and some talk about how you can actually use TensorFlow's TensorBoard with PyTorch, because all the TensorBoard requires is tf.summary writer, and you can actually pass anything to it. So you can actually pass PyTorch loss data into the TensorFlow logger as well, and then use TensorFlow's TensorBoard with PyTorch or any other deep learning network. We didn't talk about distributed training because that doesn't exist in PyTorch. And of course, deployment, there is no recommended way, although you can deploy, because it's just Python module, you can just deploy it in Flask, Django, or Tornado, or Async IO, anything. It's only been out 6 months or 7 months now, but TensorFlow has been out there now, close to a year and a half. So, but this definitely actively worked on, yes. Oh yeah, sure, yeah. So you don't want to use PyTorch if you are building something for production today, right? So you definitely want to use TensorFlow, but we'll look at a few more things where things that are, it's really fun and easy to do in PyTorch. That so there's this idea of developer productivity versus the same. You can say the same thought to Java versus Python and Ruby. Like it's like, yeah, it's faster, but then how long will it take to write that code? But if you're very efficient and you know how it works, there's no reason to switch from TensorFlow to PyTorch. But if you're starting out, then you may want to consider it because there is no new mental model to learn. It's just Python classes. Yeah, that's a good question. Yeah. Yeah, so it's exactly going to the same question there. You will see a lot of people talking about this. Is PyTorch better than TensorFlow? There is no definitive answer to this. Here is how I think about it. If you're now done deep learning, you may want to start with Keras, because in 10 lines of code, you're actually completing a Kaggle computation with deep learning. But you may want to give PyTorch, a spin. It's actually, API is really small. It's much smaller than Keras, and that's why it's easier to use. And that's why you get this. So just some celebrity tweet. You will see that lots and lot of people are talking about just this. Okay. So, and the reason they're talking about this is they all come from a research, background, and obviously when you're experimenting new things, you're not trying to wrestle with the deep learning framework. It just flows with it. Okay. And so here is an example of it. So just to emphasize, James Bradbury, Salesforce Research, MetaMind, gave a talk on recent DoD AI conference of using PyTorch to do some pre-LSTM models. I honestly don't know what it does, but he said this is all the slide, this is all the code is, okay? And there is no graph building, it's just defining a Python class over here. Okay. and then it's really the expressiveness, and it's the same two methods. You have an init method, okay, and then you are defining a forward method. That's all you're doing. In fact, in the init method is actually creating a second neural network. So that is why the pre-NSTM comes in place. So here are some resources, and most of these resources are PyTorch resources. There are some that actually do PyTorch and Keras, like the FastAI. Jimmy Howard has a lot of videos and also notes on Keras and PyTorch. The reason I have not put specifically TensorFlow and Keras resources here is because there are just too many of them out there. You can probably find them very easily. There are some of them will actually do some really good examples, like this one, Torch sample. This guy came from Keras, and he basically built a layer on top of it, which basically does. You see this line over here. This almost looks like Keras. It's actually using PyTorch, the trainer.fit, and then he's doing. So he has basically built his own library of, with the fit method that does what you could do with Keras as well. So instead of having to write 10 lines of forward propagation and backward propagation, we have this modularity. So all right. So that's how I have experimented with all three of them. I actually use all three of them in my work as well. When I use it, I mostly use PyTorch when I am trying things out, but then I've also looked into TensorFlow, and this is for a startup, so they keep coming back and asking me this question over and again. But so far, I just have PyTorch in production. I don't have TensorFlow in production. It's because I will write, halfway through TensorFlow, and I'll just I'm going back to PyTorch. So yeah, so that's there's some backup slides, but yeah, that's it. Yeah, I'll leave it here. All right. Yeah, any questions? Let me know. But it's very easy to get started. But you can, all three are really decent frameworks and good frameworks. There is, and that's what is nice about this community right now. Yeah. Not really. So I don't know. I don't know how MXNet works or how CNDK works. I looked at it briefly, but they all try to, when these frameworks came out, they were trying to compete with TensorFlow. But if I'm going to use a define and run paradigm like a TensorFlow, then I might as well use TensorFlow. Right? There's no reason to switch to any of the other frameworks. The only reason PyTorch is interesting is because I don't have to build this long computation graph, not knowing what's happening in each step, right? So, whereas in PyTorch, I could actually evaluate and look at it, look at the gradients, look at the loss function, see that the model is not training, and do all sorts of things. I have some backup slides. I had a backup slide up there. Yeah, a lot of times you will see the loss doesn't change at all. And then if all you have is a fit method, then it's really hard now to unpack that and see why the loss function is not changing. Whereas if you have access to all the weights, all the gradients right there, it's much easier. In TensorFlow, you can do it with TensorBoard, but once you have a large network, it also gets harder in TensorFlow. Yeah, I'm sure other frameworks will do just as reasonable job. Any of them will do a reasonable job. Yes.
So the fact that PyTorch does not build up a graph, right? What's the downside to that? Right? We saw this with Spark and how it's able to collapse certain operations, and the XLA framework, the accelerated linear algebra framework within TensorFlow, and see the overall graph.
Yeah, you certainly expect that compiling the graph and then running the graph must be a whole lot faster, but it has not proved so far to be the case. I think it's because all the time is taken in the GPU computation, not actually in the CPU computation. So, and PyTorch itself is just a wrapper around its own C library, so it's not really running in Python completely. So far, nobody has nobody has shown significant performance difference, but it's not been out for too long, so I'm sure there'll be use cases that they could show it. But in experiments like ImageNet, I think TensorFlow and PyTorch were, in fact, sometimes the dynamic graph computation. We just talked about PyTorch, but there's other frameworks similar to it, like precursor to PyTorch, which is Chainer, Dynet, other or the Autograd, which we did not talk about, but they all share the same defined by run. And people have done experiments, benchmarks on it, and I don't have the link here. I'll put the link later. They have not seen any difference between these frameworks. They all take the same amount of time.
So how about the distributed?
Yeah, so there is a PyTorch distributed branch inside PyTorch library. Some people are working on it, but I think the core contributors from Facebook AI research basically said that's not our priority right now. But yeah, that is something that people are working on, that people care about. Yes.
Yes, I don't understand how it's not a priority,
right?
Right. TensorFlow's whole jam is the distributed.
Right. I think it goes to this slide. I think PyTorch is not trying to serve the whole gambit. It's trying to primarily focus on research and quick iteration. And yeah, meaning it's again, I'm not a code developer, so I can't speak that it is not a priority. I'm just reading the forums, and then from those discussions, I infer that it is not the immediate priority. Is what I would say. I'm sure they'll get to it. Yes. Right. You could say the same thing about Python, right? When Rusum wrote Python, he said he never expected anybody to write more than 500 lines of Python code, right? So, yeah, I mean, you design it for something, but then that doesn't mean people will use it for that. If they find use for it elsewhere, they will use it. You have a question? Yes. Yeah, I don't know if I have necessarily good intuitions, but I can show you where I would start. Is definitely is where would you start on some of these things? So if you go to pytorch.org, I did not call out one other thing here. You see that there is a missing Windows option here. It's currently not on Windows. Okay, so it's only on OS X and Linux. So if you need to use it on Windows, you have to put it inside a Docker to use it. There is a open GitHub issue on Windows. I think what's holding them up is the different version of Visual C++ or something like that that they're trying to work on. And again, the code developers basically said, no, none of us use it, so we're not going to care about it. Somebody cares about it, do it. So if you go to the docs here, it's not that I didn't find these docs to be that useful. They're just API docs, but I actually found these two example project examples and tutorials, which are actually quite nicely put together, and they have different use cases. And then so they have the what's it called, transfer learning tutorial. They have different tutorials. Those are great places to start from, and they walk you through those steps. Yes. Yeah, if you have never done any of these three, you could certainly do Keras first, because it's like 5 lines of code. You have a model done. But I actually will look at PyTorch, is because the API is really small. Right. Oh, when you say pre-trained models, I usually start from BGG and not use any dense layer of BGG. I'll start with a pre-trained BGG 16, but a lot of people will start from ResNet, whether the 50-layer ResNet, if you don't want 150-layer ResNet. But these models will overfit. Okay, so it's like the most of the time it doesn't matter which network you choose, they're all very powerful for your examples, and you might overfit the data and you'll go back and put dropout or other means to reduce the overfitting process. So I have mostly used VG16 or ResNet 50. Right. Here you have to draw your own plot in some ways. So inside the training loop you can collect the losses and print the and then plot the losses, or you can export it to Tensor board as well. So you can actually export your PyTorch output to Tensor board. And third is that Facebook has been working on this wisdom UI. I don't know if I got this right. Wisdom Facebook, yeah. So this also they are trying to work to as a visualization flexible tool for visualizing these loss functions. I have not seen it, so I don't know. Yeah, people have talked about this, but yeah, I usually just put it inside my Jupyter notebook. I will actually print my loss function. Yeah, definitely. TensorFlow's being able to add it into the TF summary writer is definitely useful. But the problem with TensorFlow's TF summary writer is that's all part of the big graph. So you can't just add it in some function and then remove it easier. Like unless when you create the model itself or graph itself, you have to keep them so that your testing code doesn't mix with the main code that's there. Oh, yes. Thanks. Yeah. Thanks. Yeah. Yeah, definitely. Get